Hi everyone. Today let's solve a quick question called binary tree level order traversal. So what is level order traversal nodes? Well, for level order traversal, for each level, we want to visit all the way from the left to the right. So for example, in the example 1, we are starting at root 3, so let me use the drawing here. Actually, we are starting at the 3, right? The first level only is 3, so add 3 to this array in the result array. And for the second level, let me use the blue color here. You see the first element is 9, and then we'll go left to right. So second element is 20. So the second level will have this array, including 9 and 20. And finally, for the third level, let me use a different color. So you see the left element is 15, and the right element 7. So we put 15, 11, 7 in this array. Final result array will be containing 3 subarrays, and will be like this. Okay, so I think the intuition is that's very straightforward. Let's think how to solve this kind of problem. Well, for this kind of problem, we usually use breadth search because we are traversing each level by level, but not traversing from one level to all the end. And our idea is we want to include a variable called level. So level is starting at 0 and all the way to the end. Now, every time we visit, for example, visit this node, and the level is not 0, because it's root level, and we want to append a list to the subarray. So we append the list to the subarray. You see this list, and after we append the list for each level, we want to include the node. The first level only has 3. We put 3 here, and for the second level, we are growing the level to 1, right? So just change this to 1, and maybe use a different color. And now level is 1, and we also want to append the empty array. And after append the empty array, we will include all nodes from the left to the right. So let's include these 2 elements. And finally, for the third level, we are changing the level from 1 to 2. So let me use a different color. So we are changing here to 2, right? And we want to append the empty array. And we see, okay, there are 2 nodes, 1, 15, and the right element is 7. So we put 15 and 7. And finally, we turn this entire array, it will be our result. So you see the intuition is very straightforward. Now let's dive into the coding part. Okay. So our idea is first we'll write the main function, and then we'll write helper function as we did for most breadth search questions. First, we initialize array starting at 0, which is the root node level, and we need the empty result array. And after that, we call the helper function, which will run later. So passing the root, passing the level, and passing the result. And finally, return the result array. Okay, now visual main function, let's dive into helper function. So helper function will have all these kind of variables, right? And the first thing check as most tree questions is that is no root, we turn none. And after that, we want to append the list to each level, and then append the node to each list in each level. And after that, check the left subtree and right subtree and did most tree problems. Okay, with a no root, we immediately return none. After that, while the length of results, which means number of subarrays in the result is smaller or equal to level, we keep append the subarrays to the result array. And once finished subarrays for each level, we want to include a node in the subarray, right? So for result each level, we want to append the node. Well, okay. I know they would call the recursion on the subtree and right subtree. So this one should change to the left. This one will be level +1, indicating we are traversing the next level to the bottom. And then the result rate. Right subtree will be the same. It's here, to the right. Okay, now let's meet the result that works. Okay, so the current capacity and memory usage of this solution is not bad, and the coding part is clean and easy to understand. If you like this video, please subscribe to our channel, and I'll see you next time. Thank you.